The domain of a function refers to all the values that can be used as inputs for the function. On a graph, these inputs are represented along the x-axis, which is the horizontal axis. Every point on the graph corresponds to a pair x, y, where x must belong to the domain. For example, if a function is defined only for positive numbers, then the graph will only appear on the right side of the y-axis. The domain does not describe the outputs, y-axis, the slope, or the intercepts. It specifically focuses on which x values the function accepts as valid inputs. The question is asking about the concept of the range of a function. In mathematics, a function has two important sets of values, the domain and the range. The domain refers to all the possible input values, usually represented on the x-axis, for which the function is defined. On the other hand, the range refers to all the possible output values that result when the inputs are substituted into the function. These output values are represented along the y-axis. The range does not describe slopes, intercepts, or distances. It specifically refers to the collection of all y values the function can produce. The function given is f of x equals x squared. To determine its domain, recall that the domain of a function includes all values of x for which the function is defined. Since squaring any real number is possible, negative, 0, or positive, the domain covers all real numbers. For the range, we examine the possible outputs. Squaring a number never produces a negative result. The smallest value is 0 when x equals 0. As x increases or decreases without bound, x squared grows larger, giving outputs from 0 up to infinity. Hence, the range is all non-negative real numbers, starting at 0 and extending upward. When looking at a graph of a function, two important parts to consider are the domain and the range. The domain represents all the possible input values of x that can be used in the function. Graphically, this means the spread or coverage along the x-axis. If the graph continues indefinitely left and right, the domain is all real numbers. If it is restricted, such as between two vertical boundaries, then the domain is limited to that interval of x. The range, on the other hand, is shown along the y-axis. Thus, the portion of the x-axis covered directly indicates the domain. A function is a relation where each input is linked to exactly one output without repetition or ambiguity. To decide which situation represents a function, think about whether one item is paired with a single, unique match. In option A, a student can register for many courses, so one input has multiple outputs, which is not a function. In option C, a teacher can have many students, meaning one teacher links to several outputs, also not a function. In option D, a country contains many cities, again multiple outputs. Only in option B, each person has one unique n, ensuring one-to-one correspondence. A function is a special kind of relation where every input, domain element, is paired with exactly one output, range element. This means no single input should correspond to more than one output, though different inputs may share the same output. For example, each car being assigned one registration number fits the definition because one car cannot have multiple numbers. Similarly, each book having a unique barcode works since one book maps to one code. A phone number linked to one SIM card also satisfies the rule. However, when one student has more than one matriculation number, a single input connects to multiple outputs, breaking the function rule. The relation each child and their biological mother describes a mapping from children to mothers. To test if this is a function, recall that in mathematics, a function means each input, child, is assigned to exactly one output, mother. In real life, every child is born of one biological mother, making the assignment unique. A mother, however, may have more than one child, and that is acceptable, since a single output can correspond to many inputs. Option B is incorrect because some women may not have children. Option C is false because children cannot choose mothers. Option D is wrong because it is not random. A linear function describes a situation where change happens at a constant rate, producing a straight-line relationship between two variables. In daily life, this occurs when one quantity increases or decreases steadily with another. For instance, if a car moves at a fixed speed, the distance it covers increases evenly with time, meaning equal time intervals add equal amounts of distance. This constant rate of change is the key property of linear functions. On the other hand, exponential growth, exponential decay, or motion involving acceleration result in curves rather than straight lines. Only one option reflects a direct, steady, proportional relationship. The function fx equals ax plus b is a linear function. Here, b is the y-intercept, which shows the initial or starting value when x equals 0. The slope, represented by a, tells us how much the output, f of x, changes whenever the input x increases by 1 unit. In real life, this means the slope shows the steady rate at which something increases or decreases. For example, if a worker earns a fixed amount of money per hour, the slope is the pay per hour. It is not the maximum point or randomness, but the constant rate of change. The question describes a taxi fare system that has two parts, a fixed charge and a variable charge. The fixed charge means that no matter how many kilometers are traveled, the passenger must always pay 500 at the start. The variable charge depends on the number of kilometers x traveled, with V100 added for each kilometer. A linear function is suitable because the cost increases at a constant rate per kilometer. The slope of the function represents the T100 per kilometer, while the y-intercept represents the starting CC500. By combining these, the cost function shows both the base fee and the distance-based charge.
We share.
Tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.